So let's continue. We looked at correlation in the first video. In the second video, we're going to be looking at regression. Now, correlation is when we determine whether or not there is a relationship between two variables. The regression is what we do after we find out that there is one. We want to know what kind of relationship is it. And we're able to even come up with a prediction equation, which is the very first thing we're going to address. It's our regression line. Now, this is also very similar to in algebra, your y equals mx plus b. Notice that m in algebra is our slope, where in this one b is our slope, and our b that used to be our y-intercept is now our a in statistics. Now, most important part for me to remind you about is that a and b can be positive, negative, large, or small. Now, of course, we're going to keep all our calculations out to 3 decimal places. We're going to continue that. But we're actually going to calculate the regression line or line of best fit. It's also our prediction line. So let's go ahead and calculate that first. Now, on your formula sheet, you see that y prime equaling a plus bx actually has a couple of formulas, one for a and one for b. A, and again, I won't read it to you, but I'm going to write it out really quick. You can get it right off of your formula sheet. The interesting thing about A and B, the formulas while I'm writing, is that the denominator is the same on both of them. That's kind of nice to know, because that way when I'm plugging in, I can just kind of peek and copy that a little quicker, right? If you need to, pause the video while you write this down. Now, once I have my formulas written down so you can see what I'm plugging into, I'm going to go ahead and plug in down here. It is 38. And again, these are the same columns that we built before. Same columns are being used, and that's one reason we built them first. That way we can easily look back and we have everything we need to continue with regression. All right. Now, once you plug A into the calculator, you do get 0.073. It's positive, but again, it can be positive, negative, large, or very small. For B, I'm going to plug in really quick as well. In class, of course, we'll take a little bit more time and explain some other things. We're just getting the examples done, so that way if you need to take a second peek at them, you can. All right, after you plug B into the calculator, you do get 0.835. Now, I wanted the regression line, so I'm going to write it up here. Y prime is equal to 0.073 plus 0.835 x. That is the regression line. That was the first thing they asked us for. Find the regression equation. Now, predict the amount of sales if we bought 7 ads. Now, on this one, I went ahead and told you that x is equal to 7. On your studies, you'll have to know that if I want you to predict the y variable based on 7 ads or whatever your x values are on your studies for homework, you will say x equals 7 and plug in y prime, and again, that's the number of ads. Y prime is equal to 0.073 plus 0.835x. I'm going to calculate it. It's 5.918. Now, that's okay for the calculation, and if I need it in any type of equation later, hint, hint, this is what I'm going to use. But when I want to talk about it, I know that Y is actually sales in thousands of dollars, so I can actually translate it to 5,918 to write my final statement. Not all data is abbreviated this way, but this one was. So when I make my statement, I predict that buying 7 ads on the radio will generate $5,918 in sales. That's the statement that's required. Now, that's kind of hard for anybody to believe that you can actually predict to the dollar, right? So there's another calculation that we're going to do. It's called the standard error of estimate. We calculate the standard error of estimate so that we're able to give the amount of error in our prediction to the person we're trying to get to buy more ads from us. The standard error of estimate formula is also on your formula sheet. It's the sum of the y squared column minus a times the sum of y minus b, and again, I'm sorry, I'm saying it, but you can get it right off of your formula sheet, all over n minus 2. Now, all of that is underneath the square root. So when we plug in, we're able to say, we're able to plug in 286 minus our a was 0.073. Now, if we had an A or B that was negative, be careful and take care of a double negative, right? That would have occurred if you do have that. Hint, hint, right? Let me explain what I'm trying to say there. If this had been a negative 0.073, that would be minus a minus, wouldn't it? So you'd write plus when you put that into the calculator. Now, after calculating that, I do get 0.499. Now remember, this is the amount of error in your prediction. If you're predicting a value that comes in thousands, that translates into $499 amount of error possible. So you would say our prediction is good to within $499. Or you can say, I predict that you would, that if you buy 7 ads on the radio, you can generate $5,918 in additional sales, give or take $499. That's a lot more believable, and you've given them the error that you predict in your prediction. Now, to do a confidence interval, as is indicated in this last part, and again, another part of regression, in class, again, we went over how to find 99% prediction. It is 2.575 is our T sub alpha over 2. We're going to need a few more things. Our formula is really giant, and so I'm going to ask you to pause the video while we write that down. In fact, I'm going to stop and erase that and write my formula down first, and then we will talk about it. I'll be back in a minute. Okay, this is on your formula sheet, but I wanted to be able to point at a couple of things. Before I start plugging into this formula, you really don't have to. You end up noticing that there are actually only 4 numbers. Let me show you what I'm talking about. This is one number, this is one number, this is one number, and this square root is one number. The other side is identical, but it's got a plus sign where the left-hand side had a negative. All right, now let's find all the pieces we need to be able to find this. First thing is the 99% prediction interval. The 99% actually gives us our T sub alpha over 2. There is no dividing or anything involved. That's just his name. The T sub alpha over 2 that I showed you how to calculate in class is, for 99%, is 2.575. The next thing we need is our y prime. Now this is a prediction for 7 ads. So my X is 7, and we actually already calculated that, but I'm going to write it down again because there's no guarantee that you're going to have the same value like we did here for X. It can be a different one when you do a prediction interval. Our X, we're also going to need an X bar, it looks like right here. So what does X bar mean? It is X bar is the mean. So I look at the sum of the X column and divide by N. That's 45 divided by 6, or 7.5. So far, I've got Y prime, T sub alpha over 2. I know what N is. I need the standard error of estimate. Luckily, we just calculated that also, 0.499. The only other thing I'd like you to calculate before you go any further and we plug in is calculate the square root. That is the worst part. 1 plus 1 over n. And I'm going to go ahead and plug in. 1 plus 1 over 6 plus 6 times the x value, 7, minus x bar, 7.5 squared, over n times the sum of the x squared column minus the sum of the x column, that's 45 squared. Now, in class, I'll go through and show you how to plug that into your calculator. We have gotten this number. All right, so let's plug in real quick. I'm just going to go from left to right. Y prime, or 5.918, minus T sub alpha over 2 times the standard error of estimate times the entire square root. On the other side, exactly the same, 5.918, but this time with a plus sign, 2.575 times our standard error of estimate times our square root. Now, my video is getting a little bit long, so I'm going to go ahead and calculate those. 4.528 and 7.308. Now, remember, we're predicting a confidence interval for 99% confidence interval for sales of 7 ads. You want to be able to make a promise to them, a guarantee of sorts. Your conclusion here, now remember, these are in thousands, so 4,528 up to 7,308 is what's possible. So I can say I am 99% certain that buying 7 ads on the radio will generate between 4,528 and $7,308 in additional sales. All right, in class we'll actually do a couple more studies. The next one on this handout actually goes along with an Excel project kind of that you have. So I will see you in the next video.